Greetings, wonderful students, and whoever it is that's watching today and making sure everything happens the way it's supposed to. I am not sure exactly where in this lesson we will be, so take a moment, please, and fast forward to whatever section we might have stopped on yesterday. All right, so just in case we didn't get started on making this video complete, so from the beginning to the end of chapter 2, section 7, having to do with proofs and angles. So first thing we need to understand is that in angles, whenever you have angles, it is what we call an equivalence relation. And just to recap, an equivalence relation means that it is reflexive and symmetric and transitive. Reflexive just means that if you have an angle, it's congruent to itself. Symmetric means that if you have two angles, like A and B, and A is congruent to B, then you can flip them over to the other side of the congruent symbol, and that means that B is congruent to A. Reflexive in geometry is going to end up being one of the ones that's very frequently used. Symmetric sometimes. Transitive is also going to be used a lot as an equivalence relation. What it means that if you have two things that are congruent to the same thing, for example, A is congruent to B, C is also congruent to B. That would mean that they have to also be congruent to each other. So you wouldn't even have to deal with B if you know that A and C are both congruent to them, then you know that they have to be equal or congruent to each other as well. So today we're going to go through a few theorems that are important and their proofs. Okay, so adjacent angle sum theorem. Well, adjacent angles, just to recap, are two angles that are next to each other. They share a common ray. These two are also adjacent angles. They share a common ray. And so what it's saying is that if you have two angles that are next to each other, they will add up to be this bigger angle. These two angles that are next to each other or adjacent will add up to be this bigger angle. So if we know that angle 1 is congruent to angle 3, so the same number of degrees as angle 3, and angle 2 is congruent to angle 4, same number of degrees for these two angles, when you add them up, you're going to get the same number of degrees. So what this is really just saying that when you have these angles, they have to be congruent to each other as long as their little parts are congruent. Okay, we call that the adjacent angle sum theorem. They are next to each other, they are adjacent, and this one congruent to this one congruent to this one. So the bigger piece also has to be congruent. What that looks like is this. If angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, then angle CBA is congruent to angle GFE. So the big angles made of the two equal little angles end up also being the same as each other. Do keep in mind that in these, I'm taking your formalized definitions and I'm making them more understandable. If you remember way back, we said that definitions and theorems all have to be understandable in order to be a good definition. So I'm trying to make it so that in these words, you can understand what is going on. Certainly read your book, but from what I've found in past, sometimes the way that it's worded makes it more difficult to understand. So we're going to work on unraveling that. Now we've started to take a look at what proofs means. Proofs means that you're going to show that this is true under all circumstances. So we're going to take this adjacent angle sum theorem and we're going to go through a proof showing that it's true. Now you are working on learning what a proof is. So you're not going to be just given this and saying, do this proof fresh like that. We're learning on putting statements and reasons together and hopefully being able to follow the logic path that goes from the beginning to the end. So we've got a statement column and a reason column, and we're going to start with our given information. That angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And our goal is going to be able to prove that the big angle here is congruent to the big angle here. So my beginning information came from the picture or the given information, which means that we just say the reason we know that's true is it's our starting point. It's our given information. So from here, we have a little notation change that we need to make. If angle 1 is congruent to angle 3, that means it's exactly the same. It's the same shape, it's the same opening here, which means that the number of degrees are the same. But we need to translate that over into numbers. So angle 1 being congruent to angle 3 means that the measurement of angle 1 is equal to the measurement of angle 3. We've changed it over to numbers. The measure of angle 1 equals the measure of angle 3. And the measure of angle 2 equals the measure of angle 4. And that just comes because we knew that they were congruent. We can say that and think about the numbers instead. We call that the definition of congruent angles. Once we know that they are equal, we can start thinking about the numbers. We don't know the exact numbers, but we can start thinking about those exact numbers. Knowing that these two things are equal and these two things are equal, we know that it's always okay to add the same number to both sides of an equals. So if I add angle 2 over here and angle 4 over here, because they're equal, that's legal in math. I've added the same number to both sides of the equation. We call that the addition property of equality. What you've noticed is that every time I have a statement that I make, I have a reason to go with it. I can't make a claim if I don't have a valid reason to support my claim. Okay? I'm going to take a little bit of a change here. I'm going to put this on the side for a minute. I want to go and take a look at the pictures. We had a theorem called the angle addition postulate, which says that angle 1 plus angle 2 it equals the number of degrees in the big angle that it makes. So these two little pieces go together to make the big piece. That looks like this. The measure of angle 1 plus the measure of angle 2 equals the measure of angle CBA. The reason that we can say that is because of that angle addition postulate that we talked about before. We can do the same thing over here. Think for a minute what you think is going to show up. Same thing, angle addition postulate. Angle 3 plus angle 4 equals angle GFE. We need to use the three-letter method that we talked about because if I just said angle F, you wouldn't know if I meant this little angle or this little angle or the big angle. So remember, the vertex goes in the middle in naming our angles, angle GFE. Angle 3 plus angle 4 equals measure of angle GFE. So those are both true by the angle addition postulate. What I then want to think about, because my goal is to show that these two big angles are equal to each other. I want to think about the idea that I already know that angle 1 plus angle 2 equals angle 3 plus angle 4. And I want to begin to identify that. So angle 1 plus angle 2, that's the same as CBA. Angle 3 plus angle 4, that's the same as GFE. So I can take this out and replace it with this. I can take this out and replace it with this. So that I now know that measure of angle CBA equals the measure of angle GFE. I took something out and I replaced it with something else. That's called the substitution property. We can just write in substitution. So now I know that the measurements, the numbers are equal. So because of our definition of congruent angles again, I can say, well, I know that the measurements are equal. That means the angle itself, the rays, the whole thing is congruent. So my proof now is done that if I know that these two angles are congruent and these two angles are congruent, it puts together to show that the bigger angles are congruent. So I've proved the adjacent angle sum theorem. We are going to be getting to the point where you're doing your own proofs, but we're not there yet. But the only way that you're going to get used to seeing them and understanding them is if I bring you through some of them. Okay. This theorem is very similar. Okay. It talks about portions or pieces of the bigger angle. So here we have the beginning part the same. If angle 1 is congruent to angle 3, but instead of knowing that 2 is congruent to 4, we would say if we know that 1 is congruent to 3 and this big angle is congruent to this big angle, then that's going to automatically tell me that angle 2 is congruent to angle 4. So same idea, just starting with a little bit different given information. I'm not going to show you the proof of that. Like I say, just trying to get you used to the idea of proofs and seeing them. But you can see that it's similar enough in idea that if you know the small pieces are congruent and the big pieces are congruent, then the leftover little pieces also have to be congruent. We also have to start laying down the idea of some definitions that you're going to need to use through the whole rest of the course. These 4 definitions are definitions of linear pair, not necessarily being able to spit out the words that mean that, but being able to identify them in a picture. The idea of something called vertical angles, what complementary means, and what supplementary means as far as angles go. Starting with a linear pair. Okay, a linear pair, when you put them together, are 2 angles that will make a line when they're put together. They have to be adjacent to each other. So these are adjacent angles that when you put them together, you get a line. So angle 1 and angle 2 form a linear pair. Vertical angles are not adjacent to each other, but they are formed when you have 2 lines that are intersecting. Vertical angles then are angles that are made by them and are not adjacent to each other, but they are right across from each other. It's not the idea of vertical like horizontal and vertical. It's the ones I've made these two with these 2 lines. So angle 3 and angle 5 are what we call vertical angles. Angle 4 and angle 6 are what we call vertical angles. Okay, so they're across the figure from each other. They're the corners of the V's, if you want to think vertical, the corners of the V's actually meet each other, and they're not next to each other, and they're formed by the same 2 lines. Linear pair, you have right next to each other, and together they make a line. There's actually a bunch of linear pairs in this drawing as well. For example, angle 3 and angle 4 are a linear pair if you don't look at the rest of it. Angle 4 and angle 5 form a linear pair because they make a line together. Angle 5 and angle 6 make a linear pair. Angle 3 and angle 6 make a linear pair. but 4 and 6 are vertical angles. 3 and 5 are vertical angles. We have the idea of complementary angles and supplementary angles. Complementary angles are any two angles that have a sum of 90. So you add them up and you get 90. It's not that an individual is 90, but that you have two that add up to make 90. Same with supplementary. Neither one of them individually is 180, but you add them up and you get 180. So complementary, supplementary. Sometimes people will remember complementary and the word supplementary and know they add up to be something, but reverse them. And so the easy way, sometimes people will think C comes before S, 90 comes before 180, just to kind of help you fix in your mind which is which. Okay, so complementary are two angles whose sum is 90, supplementary two angles whose sum is 180. We have a theorem about linear pairs. And my theorem about linear pairs, remember linear pairs make a line, is that if you see in a picture that you have a linear pair, you automatically know that angle 1 plus angle 2 makes 180 degrees. If you remember, a line as an angle actually is 180 degrees. So since they make a line, that should just make good sense to you. In this book, they call it a theorem. In some other books, they call it a linear pair postulate. I am interested in you knowing that angle 1 plus angle 2 equals 180 degrees, and being able to use that. Okay. This one is very similar to it in that it says if you have adjacent supplementary angles, so if you know the reverse of this, so if you know that these are next to each other and they make 180, then they have to make 100, they have to be a linear pair. So 3 dots, therefore, given angle 1 plus angle 2 is 180 and they are adjacent to each other, then you know that you have a linear pair. This one will be far more the more useful because it'll be you see this in a picture and then you'll be able to find some missing pieces. Okay. The vertical angle theorem is a good one because the vertical angle theorem tells you that when you have these vertical angles like 3 and 5, those angles have the same measurement. So for example, if this is 50 degrees, this is also 50 degrees. If this is 120 degrees, this is also 120 degrees. You're going to be able to recognize these on pictures and be able to find missing angles. So both of those last two facts, that's our most important thing about them. So if angle 3 and angle 5 are vertical angles, then angle 3 is congruent to angle 5, same number of degrees. So let's, like I say, getting used to looking at proofs. Let's take a look at the proof of the vertical angle theorem. So we're going to take our way through here and start lining up some reasons to go with some statements. Let's say that we're given in this picture that angle 3 and angle 5 are vertical angles. So we're given that. We want to start taking a look and identifying some other things from the picture. We can tell by sight that angle 3 and angle 4 are a linear pair. They are next to each other, they make a straight line. We can assume from a picture straight line. Angle 4 and angle 5 also make a linear pair. So it's not really given to us, but when you are just taking something and saying, well, I'm putting this into the proof because that's what it is, we say that that's a definition. So the definition of linear pairs tells us that, okay, I've identified this in the picture, so the definition of linear pairs says that they are like this. What we know about linear pairs is that when you add the two angles together, we get, hopefully you all thought 180. Add up the two angles of a linear pair, you get 180. Add up the two angles of a linear pair, and you get 180. That was our linear pair theorem. Now we're actually using this theorem. Use the things that you've been taught before to prove a new thing. That's really the heart of geometry. You use things that you have been taught before to prove a new thing. All right, so we have the linear pair theorem tells us that they both equal 180. We should remember that since these two things equal the same thing, that they can equal each other. So we know angle 3 plus angle 4 is 180, and angle 4 plus angle 5 is also 180. So that means that these two are the same. They are equal to each other. Our property that says when you have two things that are equal to the same thing is called the transitive property. Transitive property of equality because we did it for equals. All right, so from here, notice that we have angle 4 on both sides of the equation. So if I were to take away measure of angle 4, however many degrees that is, even if I don't know the number, then I would be left with just 3 and 5. So I'm going to take away that measure of angle 4 from both sides and get measure of angle 3 plus measure of angle 5. Now, if you write down that's because of the subtraction property of equality, that is perfectly fine with me. I know some textbooks have it that. This particular publisher says, well, subtraction is the same as adding the opposite, so they lump it all under addition property of equality. So everywhere in the textbook, it will be shown as addition property of equality, even if you subtract to get to that next step. But what we're going to do is I will be perfectly fine if you wrote the subtraction property of equality here, because what you really did is you took away the 4 from both sides. It's a little more natural that way, and it really does depend on the publisher of the book, whether it says addition property or subtraction property. I will accept either. So now that I know that angle 3 is equal to angle 5, the number of degrees, that tells me that the whole angle is congruent. Hopefully you remember from the last proof, when you have equals and that tells you that it's a congruent, or you have a congruent and that tells you that you have an equals, that's our definition of congruent angles again, popping up right there for you. Okay, so I've been through a couple of very important proofs in that we've been able to take a look at the different ways that those reasons come into play. Okay, so now here comes the fun part. This is my fun part anyway, the part where you get to consider finding some missing pieces in a picture. Okay, so let's say we're given this, and your job is to find how many degrees is in A and B and C. Well, we can start bringing our way through the picture with the things that we know. One of the things that we know is that 108 and angle B are vertical angles. Because they're vertical angles, we know something about the number of degrees in them. What we know is that angle B is 108 because they're vertical. Now what I would suggest is possibly stopping the video and thinking for a minute and see if you can figure out what the other ones are. So if you pause, that's a fine thing to do. Now, angle A and this one, the number of degrees in this one plus this one, make a line. So since they make a line, you would be able to subtract 180 minus 108 to figure out what plus 108 gives you 180. So to find that, 180 minus 108 gives you 72. They have to add up to make 180 because they are a linear pair. There's the work that you would do to find that. So this one's 72. Once you know that this one's 72 without any work whatsoever, you can go straight across to its vertical angle and know that that's 72 as well. Okay, so like I say, these puzzle problems, to me, this is the fun part. When you're not really proving, but you're taking the information and you're finding the missing pieces. Okay, we have this picture. And there are a bunch of vertical angles. We have several coming into the same vertex here. So you have to think about them in pairs. So angle 1 has the sides here, goes across to this. Okay. Angle 1, we're going across this way. And we're going across this way to make angle 1. But on the other side of it, we have angle 4. So angle 1 and angle 4 are vertical angles. Angle 2, okay, angle 2, okay, I'm going to make angle 2, it goes across this way. Angle 2, if I extend it, I've got angle 2, but I'm on the other side. So angle 2, the one that's vertically across from it, is angle 5. Angle 3, okay, I'm going to go down here and kind of angle 3. If I go across here, go across here, angle 3 and angle 6 would be vertical angles to each other. So be careful, make sure you're thinking of the whole line extended. The angle stops right here. Angle 3 actually stops right here. Here's the vertex and it's out this way. But extending the line will help you find the vertical angle to it. Okay, so you can have a bigger picture that you're trying to solve, like here. And you could be asked to find angle A, B, C, and D. So it'd be a good place to pause it right now. But since I'll assume that you've paused it, and then we'll take a look now at the explanation. 34 degrees. Here's our vertical. So B is also 34 degrees. Oops, I need this one. Different pen. So B is also 34 degrees. Okay, right across here. This little box in the corner here tells you that you have a right angle, which is 90 degrees. So this 90 degrees can come all the way across here to angle C. So C is 90 degrees. So then that leaves us, well, what about D? Well, interestingly enough, all together up here, we have a line. So it's kind of like doing the linear pair postulate, but we've got 3 angles now. They all make a line together. So I've got my 34 degrees, and I've got my 90 degrees. So 34 plus 90, 124 degrees, takes me all the way from here to here. So I'm trying to find this other piece for what makes A. So I'm going to take 180 minus the 124 and get 56 degrees in here. So 56 degrees in A. And what you might also notice is we have another situation where we have here, we have here, another vertical angle pair right here, vertical angles. So D is also going to be 56 degrees. So there's your explanation for how that one worked. Okay. There it is. And there it is. And then we have a few more postulates, theorems that you're going to, when you do your assignment, you're going to be working on applying these. Okay, so I'm going to explain them to you. One of them is that supplements of congruent angles are congruent. Theorem 2, Chapter 2, Section 7, Theorem number 7. So supplements of congruent angles are congruent. So in other words, if A and B are supplementary, and you know that angle C and D are supplementary, that means that if I added A and B, I'd get 180. If I added C and D, I'd get 180. And B is the same, or B is congruent to C, meaning that this one and this one have the same number of degrees, then our conclusion would be that this A and this C have to also be congruent. Okay. All right, so how will we possibly know that? How we would know that would be, let's do an example, okay? Let's say that angle B is 150 degrees. Okay, so if angle B is 150, it's not going to let me do this, so let me pull this diagram out for you. Okay, put it over here. Paste. Okay. So let's say that this was 150 degrees. Okay, because they're congruent, this one would also be 150 degrees. A and B are supplementary. Supplementary means that they have to add up to be 180. So 180 minus 150 would give you 30. Because we would do the same math over here, this one would also be 30. So it only stands to reason that our conclusion would be that these two have to be the same number of degrees. Supplements of congruent angles are congruent. Okay. Another way of putting that is if A and C are both supplementary to B, then A is congruent to C. That's putting it the same theorem into other words, but it means the same exact thing. We have some other theorems. Okay, I'm going to run through them. I'm going to make some diagrams for you to go with this. You can include this in your notes wherever you want it to be to help you to understand what these theorems are actually saying to you. Okay, so here's our first one. Complements of congruent angles are congruent. Okay, all right, so let's say that angle A and angle B are complementary. Complementary means that you could add them up to be 90 degrees. Angle C and angle D are complementary. That means that you'd add them together and they'd be 90 degrees. Complements of congruent angles. Okay, well, let's say we're also given that angle A is congruent to angle C. Okay, so if these two are the same and you're adding them to something to get 90, you're going to be adding them to the same number. So for example, if angle A is 40 degrees and angle C, that would make angle C also 40 degrees. Because they're complementary, angle B would have to be 50 degrees. Same math, this is also 50 degrees, so the complements B and D of the congruent angles A and C are also congruent. So that's the explanation for that one. This next one should just plain make good sense. All right angles are congruent. We're going to use that in a proof, so it will be important even though it seems trivial. So let's say that angle A is a right angle. Okay, well, being a right angle, what that means is that angle A equals 90 degrees. Angle B is a right angle. So the measure of angle B equals 90 degrees. They're both equal to the same thing. So that's why all right angles are congruent. They all have a number of degrees of 90. So we have that, the explanation for that one. Congruent supplementary angles are right angles. Okay, well, let's think about what that means. If you have two angles that are congruent, that means they equal each other. So you would have measure of angle A, let's call that X. Measure of angle B, if they are congruent to each other, that would mean that they equal each other. So B is also X. Supplementary means that when you add them, A plus B, you get 180 degrees. So if I have two of the same thing that add up to be 180 degrees, each one of them has to be 90, which is a right angle. So here's the thing with these. The words have meaning. Writing out what the meaning is helps you to understand. When you're going through and you're doing your work, take the words, make them into something understandable, whether it means that you're taking them and making them into pictures or whatever it is that you're doing to help yourself understand. You take the words and make them into something that you can understand. Okay, so here's another one. These also, if one angle of a linear pair is a right angle, then so is the other one. Let's see if I can get this to delete. Okay. If one angle of a linear pair, so let's think, what do we know? We know what a linear pair looks like. So I'm going to just throw this right in here. A linear pair means that you've got two angles that come together to make a line. Okay. Oh, wait a minute though. It says if one angle of the linear pair is a right angle. I have a linear pair, but neither one of them is a right angle. So I need to change my thought. I need to make sure that one angle of my linear pair is a right angle. Okay, there we go. So one angle of my linear pair is a right angle. So that makes it 90 degrees. Since it's a linear pair together, they have to make 180. That one's also 90 degrees. So if one angle is a right angle, the other is also right, and that is how that one works. All right, so your job then will be to practice, 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 ask questions, help each other, and I'll see you all on Monday.